Hello, everyone, and welcome to our final project demo. We're a team. We're very excited to share with you the result of our final project and the progress we have made over the past few months. Our project is a blog service, which is a multi-purpose blog website with many different microservices. It basically aims to create a relatively small-scale blogging service in which the communities can share their thoughts and chat with each other. Throughout the demo, we will walk you through the key features and functionalities of the project and demonstrate how it will be used in real-world scenarios. We have divided the demonstration into the following sections, and I will start off with the architecture of the project. The diagram below shows the overall architecture of the project. So once the users clicks into our website, they're going to first encounter the first layer, which is the Amazon CloudFront. It basically integrates our Angular front end, which is stored in S3, and the API gateway. Amazon CloudFront also automatically converts HTTP traffic into HTTPS traffic. Our applications contains three core microservices that are responsible for handling user registration and login, posting blogs, and posting comments, respectively. The user microservice and the comment microservice are deployed on EC2, and the blog microservice is deployed on Elastic Beanstalk. Within the user microservice, we have used two APIs to enhance the user's experience. A fun fact API is used to show the users a fun fact every time they refresh the window, and a profanity API is used to filter out profane words in the user's self-introduction summary. Our application also contains a composite microservice. It basically connects the blog and the comment microservice, and it's responsible for displaying the number of posts and comments a particular user has created on their dashboard. The composite microservice is also deployed on EC2. The middleware in our application uses Amazon SNS and Lambda function, and it's responsible for sending an email notification to the administrators of the application when a new user registers. All of the communication to each microservice is fully managed by the API gateway.
Use API Gateway to integrate all the microservices. And here's a list of all endpoints we use. Take the first endpoint as example. Outpost is used to retrieve outposts from database and show them on the main page of the website.
This documentation includes all the paths for our application, which have all been tested and are working correctly. We use the CloudFront to encapsulate both the API gateway and S3 bucket. We also have behaviors that direct to API gateway's path. This service provides JSON formatted requests and responses with various status codes to indicate success or failure. It has been tested using Postman and has an ER diagram to illustrate the structure of the service. It also includes pagination for easy access to all user information and provides a hyperlink to access each user's dashboard. We support retrieving a user by their username or email as a query parameter, and each user has linked data connect to their post page. Users have the option to sign in using either their username and password or through Google OAuth 2.
When a user logged in through Gmail, we will temporarily store the user's public ID token in the local storage of the user's browser. And in order to identify and authenticate the currently logged in user and protect the user's information, whenever the user is trying to make interactions with our website or database, we will send the user's ID token to our Flask backend and verify the integrity of the ID token using a Google API client library.
The user dashboard will automatically load a new user's Google basic information and retrieve saved data from the database for existing users. We have also implemented 2 external APIs, a fun fact generator and a profanity filter.
The second microservice that we have is a post microservice. Within this microservice, users have the option to view all available posts online or their own posts. Post page shows a summarized view of each post that includes poster ID, post time, title, tags, and number of comments behind it. We did a simple select statement for each of them, sort the return entries in descending order so that the newest post is at the top. The second feature within this microservice is creating a new post. Users are prompted to fill in the title, text, and content fields, and simply press Add to add to the database. Title and contents are required fields, while tags are optional. There will be an alert show up at the top indicating whether it was successful or not. Then they will be redirected to the alt post page upon success. The database operation here is a bit more complicated than we had earlier. When a new post is created, we always want to assign unique ID. This field will also be used as a primary key. Instead of generating random unique IDs, I want to generate IDs with a function that gives them some standard code that makes them recognizable, so that in the future we have a more complex feature coming up. Unique block ID is capable of providing us with sufficient information. Our design was to concat owner ID and total post, with a dash separating them in between. In this case, every time when we are adding a new post to the database, there is some extra work we need to do. Our approach was to use the aggregation function, compute the maximum number of total posts for the current user. If 0 entries are returned, we can tell that the user never posted anything in the past. Otherwise, we get a new post and adding 1 to what is returned.
Here is our middleware part. We have used the AWS Lambda and the Amazon SNS to design for it. Every time when a new user has registered, like you can see here, well, the specific email will receive the message that you can see here, the notification, new user has been created.
For the common microservice, aka sublog microservice, it allows users to interact with others in the community. As we can see on the left, users could add, delete, and read comments under the post. When we look at the green button and yellow button, users could also like or dislike the post, and read total number of likes or dislikes for the post. Here's a list of endpoints for this microservice on the left, and a schema of database used for this microservice on the right. On this page, we show several Postman examples of calling our APIs, including creating, reading, and deleting a comment on their post. Last but not least, we have an importing function to notify users when someone else comments on their post blocks. As shown in the screenshot, users will see a tiny bell on the profile page when someone else comments the blocks posted by the user. And if users click on it, it could further show which specific block has new comments. In addition to our 3 separate microservices, we built a composite microservice which utilizes blocks microservice and comment microservice. As shown on the right, the composite microservice presents number of blocks and number of comments the user has created on the user profile page. Another function of this composite microservice allows users to view the number of comments for each post on the main page. As we can see on the right, there is 1 comment under the League of Legends World Championship post and 1 comment under my first post.
We also have a CI/CD feature which checks the operating system, Python and Node.js versions, install dependencies, and most important, automatically deploys our composite microservice to the corresponding EC2 server when any collaborator push or merge into the main branch on GitHub. The last part is the delegation of our project. We have a fabulous team and everyone in this group did a great job. Thanks.